Hello friends, here is a question worth pausing on. The protocol your browser uses to fetch nearly every web page was designed in 1974, over 50 years ago. RFC 675 gave us TCP, and the core of that design has barely changed since. Now, a quiet but massive shift is underway. As of June 2026, every major browser, Chrome, Edge, Firefox, and Safari, ships HTTP/3 natively, and HTTP/3 does not run on TCP at all. It runs on a completely new transport, called QUIC. Most developers still think and build in TCP terms, which makes this the most important transport layer change in decades. In this video, we will understand exactly why that shift is happening, and when it actually matters. Alright, let us start with the workhorse. TCP, the Transmission Control Protocol, was designed to be reliable. Before your browser can send a single byte, it runs what is called a three-way handshake. The client sends a send packet, the server replies with SYNAC, and the client confirms with ACK. That costs one full round trip before any data moves. On top of that, TCP guarantees ordered delivery. Packets must arrive in exactly the sequence they were sent, and the protocol uses congestion control to avoid flooding the network. These are genuinely smart ideas. The problem is that TCP lives deep inside the operating system kernel. Updating it means updating every router, firewall, and load balancer in between, a layer of devices called middle boxes. That ossification is precisely why, after 50 years, the web community decided to build something new instead. Next, let us see where that limitation bites hardest. Here is the hidden problem. HTTP/2 was a big improvement over HTTP 1.1. It introduced multiplexing, meaning your browser can load HTML, CSS, and JavaScript in parallel over a single TCP connection. That sounds great, but there is a nasty trap. TCP treats that connection as one ordered stream of bytes. If a single packet is lost anywhere, TCP stops and waits for the retransmission before delivering anything that came after it, even data from completely unrelated requests. So a lost packet carrying one image can freeze your JavaScript download too. This is called head-of-line blocking, and the cruel irony is that HTTP/2's own multiplexing feature makes it worse than HTTP/1.1 on lossy networks, because you have put all your eggs in one TCP basket. QUIC was built specifically to fix this. Let me show you exactly how. Now look at this. QUIC solves the head-of-line problem with 3 key upgrades. First, independent streams. Each request gets its own QUIC stream, and loss on one stream only pauses that stream. The rest keep flowing. Second, a faster handshake. TCP plus TLS takes 2 to 3 round trips before your browser can send real data. QUIC combines the transport and cryptographic handshake into one step. 1 round trip for new connections, and 0 round trips for returning users who already have session keys. On a mobile connection with 150 milliseconds of latency, that saves 150 to 300 milliseconds instantly. Third, connection migration. TCP identifies a connection by your IP address and port. Change networks and the connection dies. QUIC uses an opaque connection ID instead, so switching from Wi-Fi to a mobile data signal is seamless. The connection simply continues. Up next, how much of this is actually deployed right now? Alright, here is the 2026 picture. Depending on how you measure it, HTTP/3 runs between 21 and 39% of web traffic. Technology Checker tracked actual page loads between January and May 2026 and found 21%. Cloudflare reports 35% across its edge. W3Techs counts 39% of websites as having support. The gap reflects methodology, not error. But here's the interesting part. Adoption on fast networks has plateaued, and a 2024 peer-reviewed paper from the ACM Web Conference by Zhang and colleagues explains exactly why. On a 1 gigabit connection, QUIC delivered up to 45.2% less throughput than HTTP/2 in Chrome. The cause is that QUIC processes acknowledgements in user space, not the kernel, and most Linux systems still lack UDP generic receive offload support for QUIC traffic. The gap starts at around 500 megabits per second and grows from there. On mobile and lossy networks, though, the story flips completely, and that is where the decision really lives. So here is the mental model to take away. QUIC wins on mobile, high-latency connections, and any network with real packet loss. That covers most of the world's phone users, and it is exactly why NordVPN announced in 2026 that it is adding QUIC into its Nord Whisper protocol to make VPN traffic blend in with regular browser traffic and bypass deep packet inspection. Cloudflare and Akamai have both deployed QUIC at scale for the same reasons. On the other hand, if your users are on fast fiber above 500 megabits per second, TCP plus HTTP/2 still holds the throughput edge until kernel-level UDP offload becomes universal. The good news is you do not have to pick one forever. Deploy both and let the protocol negotiate automatically, which is exactly what every major CDN already does. Start with RFC 9000 for the transport spec and RFC 9114 for HTTP/3 if you want the full technical picture. Thanks for watching, and I will see you in the next one.